Is there supposed to be some, is this the clicker thing? Okay, yeah, so it's good to be back in Berlin. Actually, the story of this whole stuff started in Berlin. I guess I met Chris Hobcroft, and I was with Andrew, and we started with a hackathon. We made this dboot project, which is a decentralized network boot, or network boot from a decentralized backend. So then that has to deal with the content addressing and all these issues that you have to deal with in decentralized storage. So we moved on to thinking about decentralized container registries. We applied for EF grant, and we decided on which part would get funded. That would be something about like analyzing the storage landscape. And so this is what precipitated from that. So kind of round circle from ETH Berlin a few years back. Okay. So I guess we need to say what is the thing that we're talking about. So what are storage systems, and what do we really expect from them? We want to be able to write in objects, and we'd like to ideally be able to pull those out. So if these are online, already an example of something like this might be something like Pastebin or HackMD or Kim.com's Mega Upload. Notice these have no guarantees whatsoever. You can put something there, maybe you can get it out. If we add some payments to the mix, then you'd want to be able to get some type of guarantee that your stuff's going to be there when you need it to be. So we want to be able to reason about these guarantees. In TradCloud, you have what's called these SLAs, the service level agreement. I guess you have to hope that that's true. I guess maybe you could resort to some type of court issue or something if something goes down. But what's going on in decentralized systems is that now we have these new cryptographically backed guarantees. There's a lot of research going on to this. We'll talk more about it later. But nicely, we should be able to reason about the durability using cryptography and some consensus theory. And maybe one thing to keep in mind a bit throughout the talk is like the idea of whether something should be mutable or not. Not always. Sometimes we want immutable things. On the other spectrum of that is like hot storage. Okay, so what should you get from this talk? Maybe what shouldn't you get from this talk as well? So I'd like everybody to be able to reason about and to compare and contrast various ecosystems. I noticed that when everybody talks about even looking at some of the previous questions from the questions from the previous talk, I noticed that there's a little bit of confusion about some things. For example, confusions about what IPFS does. I want to dispel a little bit about these misconceptions. And I want to talk about like how did we determine what metrics that we use for this StorageBeat evaluation framework. And hopefully at the end, you'll be able to think about decentralized storage systems and figure out how to fit those into your DApp, if you like. So what should you not get from this talk? We're not going to complain about any specific storage system or say that one's better than the other or produce some linear ranking, okay? So we should also say some examples about some of the things we're talking about. So we want to be able to compare both decentralized and centralized things in an apples-to-apples sort of way. So everybody's familiar with these things: Dropbox, Amazon S3, and Google Drive. All of these have several different tiers. Amazon S3, for example, has some very like cold storage, glacier type tiers. There's hybrid models. The only one I know of right now is Storage. This is a registered company, but it's also participatory. You can have decentralized participating nodes storing objects. And okay, here's kind of the meat of the talk. So unfortunately, I didn't write the word walrus here. It should also be here. So Filecoin, ETH storage. Sometimes people don't think about this, but Ethereum itself is also a way to store something. If you wanted to store, for example, like a gigabyte of state in Ethereum, costs around like tens of millions of euros. That's not ideal. If you wanted to do it in blob space, that could cost you, I guess, tens of thousands of euros. Then there's a Swarm codex, Arweave. This writes into this is its own chain. All of these are very different from each other. And notice I've like crossed one thing out, IPFS. So this is not a storage backend. But one thing that we could talk about, what is IPFS? IPFS is a system for discovery and routing, and it does have some fallback mechanisms for relaying things. But it does not specify how to store anything at all. Moreover, it's not incentivized. It's an altruistic protocol. That said, there's lots of things that use IPFS. There's a whole cottage industry of pinning services that live on IPFS. For example, Pinata, Storacha, and things like this. Okay? So now that we have some examples of these storage systems, who uses these things? Who uses storage in general? So there's Web 2 applications. Often they need to have they need to have low variance on request, which are geospatially distinct. It's very CDN-like behavior. Some businesses, for example, like brick and mortar businesses, they might not need to have quick access to data. For example, they have some video camera that stores something, and they have some archival video, and they put it away. In the Web3 case, what's the types of usage of storage? So some things need to be right there at the chain. An example of something like this would be Uniswap or any type of AMM. Another thing that doesn't need to be right on the chain, but possibly kind of adjacent to it, some small positive distance away, something like a roll-up that needs to publish its blocks. I guess this happens quite a bit on Celestia. And then how about, dApps. A lot of people say we're going to make a DApp, so a decentralized app, and then they say it's got some data and it stores it somewhere, and I always have to ask them, okay, where does the data go? It's always like, oh, it goes IPFS or something. So, yeah, it seems to be that there's like, if you make a DApp, there's some type of community opinion that coaxes people to want to use some type of decentralized storage along with it. Great. So, yes, this happens with some L1s. For example, I heard recently that Luxo L1 has some type of metadata that they like to associate, and they're also using some type of IPFS pinning for that. So I guess we can summarize real quick. So who uses decentralized storage and why? So anyone who feels like they need like cryptography-based guarantees, or any project which public opinion is pushing the way towards using decentralized storage. Anyone who wants to store data in some type of anonymous way so that the data is can't be subject to a subpoena, for example. Also related to number 3 is this number 4, which is unstoppability and censorship resistance. These seem to be the core use cases of decentralized storage today. Okay, so just as I wanted to say that we're not going to produce some type of linear ranking, I just want to have a big picture up for just a second about how to think about multiple market players coming in and filling in niches. So if you have two different metrics, for example, we can have one being distance to the chain and the other being cost. There can be highly inefficient solutions, for example, those up there on the light gray boxes, and then highly efficient solutions along the bottom forming this boundary. That there is called a Pareto boundary. Let's look at an example. These are not providers, but these are some use cases that we sort of just talked about. So you think about AMMs needing to be really close to the chain. If you think about this x-axis being the distance to the chain, then and price going up. Clearly, Ethereum is going to intersect at some point. That's where this blue line's intersecting there. So there's a bunch of inefficient services that live out there. These consumers will try to use the most efficient services, and that's along some Pareto boundary. You might think at the top left there is Ethereum itself, and possibly Celestia, and then over in these dApps, maybe using Swarm and Codex and things like this. Then further down, like Twitter, this has nothing to do with the chain, so it doesn't even matter. And for example, like pictures of your grandma or something, you can store in cold storage or put it in Filecoin, where you don't need to access it extremely quickly, right? So what are the types of things that we can use to compare storage systems? So there's costing, performance, and then the risks and guarantees. So here's a list of stuff that I would like to measure, or that a lot of us would like to measure. There's probably more things than this. Important things is like capacity rents. How many euros per gigabyte month does it cost to put something somewhere? There's also like CDN likeness, like how well are things geospatially distributed, and is there, for example, if someone makes a request from India to makes a request in India, and someone making a request in California, are those going to get the same latencies? There's a little bit abstract thing, which is this distance to chain, which I mentioned earlier. This is quite hard to write down exactly how to do that. I think this deserves more research. Another thing is a UX type issue. How hard is it to use? Like, do you need to fumble with strange tokens and deal with DEXs and APIs that don't work or something? Another important thing is, of course, egress. Latencies, what is that? We can talk about latencies and bandwidths. We can also talk about error rates and timeout rates. There's also correctness. We can talk about the cost, which is the cost of the egress. A lot of times you see these banded situations where the first several gigabytes are in one tier of fee, and then the next several gigabytes get cheaper, something like this. In general, you can describe this with some type of a cost function from the naturals to the reals. And finally, we'd like to measure or observe guarantees and be able to compare those. There's kind of a wish list on this slide. So this is what we're currently actually doing with StorageBeat. It's an unfunded project, so we're not working super fast. We're currently measuring egress latencies and bandwidths. We are not dealing with geospatially distinct requests. All of our requests right now are originating from a data center in Helsinki. We would like to change that. Pricing. So we do report on pricing. We manually look this stuff up. We had to put this into the website by hand. So we're measuring, we look up capacity rents and egress costs. And basically in a tooltip kind of way, we say something about the guarantees. I would really like to be able to say something, make some really nice theoretical comparison about cryptographic guarantees. More on that in a bit. So here's how we'll do a performance measurement. Everybody's familiar with these types of graphs that you would see, like if you download something, you see your download meter, like it starts off with a bandwidth quite slow, and then you get to what's called a steady state. So that's called steady state throughput. So in order to measure that, we'll download like a 100 megabyte file, and that should be at a steady state. We'll measure the bandwidth at that point. And we define the latency to be the amount of time it takes to get the first byte of the response. And the way that we report it, I'll show a picture of the website in just a minute. The way that we report it is we use percentiles. So when you say a P50, that's how most users experience the system. And something that's in P95, that's 5% of the time it gets that bad. And P99 is like these really bad tail events. But these are important to take into account. Here's some challenges for some of the measurements. What looks like this Depeche Mode logo or something is this is actually latency. These are actually latency distributions across 25 different servers. Some of them actually are trimodal. The important thing to notice here is that we don't even have, these are not Gaussian. So I think there's some more work to do in order to really refine how we're measuring the latencies of things. We need to infer some of these distributions, that is do statistics and figure out these parameters. And another issue is that there's, when you're dealing with decentralized systems, you have choice of endpoints, and they all can behave radically different. So how do you say something about the system as a whole? And even further than that, which is a nice comment we got from Chi-Jo on our ETH research post, is if you think about Ethereum itself is a good example. Like there is every node is even running possibly very, very different node software, which is tailored for some very specific application. And it can be like this across decentralized storage landscapes. So it's kind of like the protocol versus implementation distinction. Okay, so we start to look at what this actually looks like. The way that we deployed it is we got an ENS domain. So here's a bit of dog fooding in a good way. We got an ENS domain. We deployed it into IPFS using Pinata pinning service. And we use an immutable front end. This is thanks to content addressing. Right now, it's a static website. We would like to have like some active things that run in the background and produce an Oracle feed into this. That hasn't been done yet. We're looking for volunteers. And big shout out to Pavel for producing this Bloomin' deployment app. I'll go ahead and leave this up here for just a second. This is what it looks like, actually. So I think I've said all of the columns. Yeah, and so we read the capacity rents, and then one of them we put a normalized version of it. So what is there left to do? There's actually a lot of theoretical. My background is cryptography, so I think there's quite a bit of. I'm not like a cloud storage person. Like my background is cryptography, so I think there's a lot of interesting problems associated with this, especially when you go into the direction of CDNs. And I noticed that as one of the questions in the previous talks was something about retrievals. Anytime you have retrievals, you have this issue of how can a verifier be sure that a sender sent something to a requester? Either one of those people can default or lie, right? So this we call the unicast transport problem, and I think this deserves a lot more work, and it seems to be hidden and swept under the rug in a lot of things, all across a lot of systems. The other thing is we would like to do more theoretical work on producing nice, well-defined comparisons across cryptographic consensus-type guarantees. One idea here is to use this Goldwasser-Macaulay simulator framework. What I have, this is an example of a simulator framework for a really common thing, which is in CPA. I guess any cryptography people here are probably familiar with this. One can compute advantage functions for something, and these advantage functions can be compared. And finally, I guess, we just need to get some momentum going and some more volunteers, and that's about it. If you'd like to get in touch, we've got a Telegram channel, which is called Uncloud Open Research. There's a StorageBeat, a GitHub. There's a lot more written there on the GitHub. There's also an ETH research post outlining a lot of this stuff. And you can contact us at Stuka. That's it.
All right, thank you very much. We have a few questions. So far, it's two. I think one was split into two posts. So first one, do you compare systems by the quality of their SLAs, example storage proofs?
Good question. Currently, we do not. Like right now on the website, we basically give like a tooltip of what the SLA is. We'd like to do a lot better.
Okay. All right. Second question. Isn't it weird to compare these systems side by side when they are sometimes in very different categories? DA, CDN, hot storage, cold storage, etc.
Yes, I think it is weird, but this is why I wanted to accentuate that we're not looking for some type of linear ranking, and I really want to say that we're looking at this from a Pareto frontier point. Yeah.
Makes sense. All right, thank you so much. And our next talk. Oh, there's another question. Yeah, it's a bit of a delay, so that'll be a difficult. I hope I don't die here. Are you actively adding or benchmarking projects now? If so, what is next on your list?
Yes. I forgot. I didn't have time to mention. We're using something called artillery in order to produce these benchmarks in these workloads. A current next step is to produce more workload for the artillery benchmarks. Yep.
Perfect. All right, so no more questions. Thank you so much. That was great. And yeah, we'll continue in a few minutes.